In this video clip, we'll take a look at a sample program for Brookshires Simple Machine. For Brookshire Simple Machine, or we will call it SML, there's about 7 types of instructions. First one is load store memory, is to load and store values into register or store data from register to memory. Then we have register movement, which you can transfer data between registers. The third type is we can add to complement values or add floating point values that contain in the registers and store them back to the register. The fourth type is logic execution. We can perform OR and execute OR. Then we can perform the rotate right. For the rotate right, we shift the value to the right, and then we bring the most right bit and put it on the most left bit. Then we have conditional jump, okay, and then we have halt instruction. To make it more clear, let's take a look the list of the instruction. So if the instruction contains opcode value 1, this is a load register instruction. The pattern got to be RXY, means for this instruction, it will load the value in the memory whose address is XY and then store the value into register R. For opcode value 2 is also the load register instruction, but it will load the value XY to register R. So this is different than the opcode 1, because for the opcode 1 it load the value from the memory whose address is XY. This one load the value XY itself into register R. For the third opcode is the store instruction. This instruction is to store the value inside the register R into the memory whose address is XY. For opcode 4, we have operand pattern 0RS. This 0RS means 0, it means the values must be 0 for this part 4-bit. And then we will move the data from register R and copy it to register S. Note that for this instruction, the value inside register R still remain the same, but for register S is being copied the value from register R. For opcode 5, we will add value from register S and register T and put the result in the register R. Note that the additional for this instruction will be performed as if the value are 2 complements. For the opcode 6, still we also have an add instruction, but this one is for floating point. So basically we will add 2 floating point values that store in S and T and then put the result in R. For opcode 7, the CPU will perform the OR of the bit patterns stored in register S and T and placed in register R. And for opcode 8, we perform AND operation. For opcode 9 is for exclusive OR instruction. For opcode A, it has operand pattern R0x. This means we will rotate the value in register R one bit at a time to the right. This will perform X times. Means if we have the value 2 at this location of the operand, we will shift the value to the right 2 times or 2 bits. Note that for each time we shift the value, we will bring out the rightmost bit and then put it back into the leftmost bit. So basically we rotate the values. For opcode B is jump instruction. It has pattern RXY. This means we will compare the value inside the register R with the register 0. If both values, the values inside those two registers are equal, the CPU will jump to the location XY. This means the program counter will be set to the value XY, and then the next instruction will be fetched from this location. And lastly, the opcode C indicates halt instruction. This means the CPU will stop. The students can perform the testing in the SML emulator. This is the URL that you can get the emulator. The emulator was written by Joel Estrom. It is in HTML with JavaScript, so it can be executed on any web browser. It can be run on browser on the PCs, notebooks, or even tablet. For this emulator, we have the memory, which you can change the value, and it has the details of the control unit. For example, program counter, instruction register. It also show the decoded instruction, what it means for the instruction that's put inside this instruction register. And it also show the current step in the machine cycle. For example, in this picture, the program counter is 06, means the next instruction will be fetched from the address 06. The instruction register is contain 5112, which means this instruction is additional instruction. It will add value in register 1 and register 2 together and store in the register 1. And this shows that the CPU is in the decode step of the machine cycle. On the left side, it shows the current content inside the register from register 0 to register F. You can run the program inside the SML. You can go into steps to see the detail of instruction of execution. You can clear and run. For clear and run means it will reset the program counter to 00 and then start the machine cycle by fetching the instruction from memory address 00 and 01 and then continue in execution until it found the instructions halt instruction or C000. For clear CPU means it will reset the CPU. We can play with this. Please go to the URL in this. Let's take a look at the example of the program. Here is a simple example to increment the value at the memory. In this example, we will increment the value of the memory address 0A. So this is the program. On the left side, assign indicate the address of the value on the right side. This means 11 is at memory address 00, 0A is at address 01, 22 is stored in the memory address 02, 01 is stored in the memory address 03, so on and so forth. Let's take a look at each instruction. So the first instruction at memory address 00 is 110A. If we take a look at this table, you see that the opcode 1, you see that this is opcode 1 with operand 10A. Okay, so once it being fetched, it will be decoded. So you see that they have instruction type opcode 1 and then with operand 10A. So for opcode 1 is load register with the content from the memory with address XY. So the operand pattern is RXY. So for this case, you have 10A means we will load the content from memory address 0A and put it in register 1. So this is how we can show it. And then the next instruction is 2201. So its opcode is 2 and operand is 201. So for opcode 2, okay, is a load register with a bit pattern XY, means we will load the value XY into register R. So in this case, we will load the value 01 to the register 2. So you see that this is different. Okay, for the first one is load the content of the memory 0A. This one load the value 01 to the register directly. Next one is 5112, which is the additional instruction to add two register together. So basically, and then we have 310A, which store value from register 1 to the memory address 0A. And then we have halt instruction. And suppose that at 0A we have value 10. So for this sample program, first we'll load data in the memory at address 0A into register 1. Based on this, the value 10 will be loaded and stored into register 1. Then we will load value 01 into R2. So right now R1 has value 10 and R2 have value 01. Next instruction is to add those two numbers together. Okay, so you add 10 and so on together, which result to the value 11, and the result will be stored into R1. Then we will store the result in the value in the R1 with the result addition back to the memory address 0A. This means after this instruction, the value of the memory at address 0A will be changed from 10 to 11. And then we halt the execution. And this is a simple sample program. You can try this on the emulator. It's not that difficult. Okay, please try the emulator to make sure that you understand this program.